So today we're talking about quadratics. You might ask, well, didn't we already learn about quadratics? Yes, we did. We've learned the basics of quadratics when we learned about the simple functions. But I need you to remember everything we've learned there, and then we're going to go from there a little farther. All right. See that red parabola that I've graphed here? That guy has got a lot of complex parts that you already know. What's that bottom, the lowest part that it gets to? It's called the vertex, yes. That vertex right here is a really important point. It's a spot where it changes from going down to going back up again, if you read from left to right. It's also called either a minimum or a maximum. In this case, what do you think it would be? A minimum, because it's the lowest it ever goes. Okay. Next, something that you probably know without even thinking about it is that it's always go over one and then up one. And then there's always a mirror that does the opposite over here. Goes over to the left and up one. Unless it's been stretched. Yeah. And so if it's a kind of a plain vanilla parabola, it's over one, up one, and then what about over two? Up four. Okay, so over two, up four. And how about over three? Up nine, because it's just take the number down here and square it, right? That's the point. These all have an x squared in them. Okay. Do you remember how this is different? It's got quite a few things changed about it. Some thoughts? AK. The 2 stretches it vertically. You are correct. It's twice as tall. So if I was going to graph this thing, I'd take every single point and move it up 2. Is that what you mean by stretched vertically? Twice as tall. So I just move every point up 2. Is that what you're saying? No, that's not what you're saying. Times by 2 is different. So I'm going to take each point and its y value and make it twice as big. So what about this point at the bottom, 0, 0? Well, it's still there. So my new point goes right on top of that. Okay, because it stretched vertically. Remember, the y part is what's getting stretched here. So it doesn't move. But instead of going on this one, instead of over 1 and up 1, it's over 1 and up 2. Okay, and then this one, over 1, up 1, instead it goes up 2. It's always a mirror. There. That one wasn't quite high enough, bothering me. Whoa! I stretched it somehow. Okay. Oh, now the background. Okay. I'm going to leave it there. It looks fine. Okay, then I'm going to go, instead of over 2 and up 4, I go over 2 and up 8. All right. There. And there. Okay, so the black one, it's kind of skinnier. If you imagined the red one was like elastic, like a rubber band, and you grabbed it and you pulled it up, it would look like the black one. It could kind of stretched up. Okay. Next thing is this, and you could either talk about it in terms of moving, or you could say that gives me a new what? Vertex. The vertex was at 0, 0, and now it's at what? 3, 1. Do you remember that? The first one's counterintuitive because it's on the inside, so we don't use -3. Or still, yeah, we don't use -3. We use 3. All right. So let's see. I think I've covered all these major points here that you had to know. The vertex. Minimum, maximum. The whole 2 points on each side thing. What I'm trying to say there is that when you graph these, it's not okay to just like put a dot and then kind of go, it goes like this. Okay, well, that's fine for just talking, but when you're actually graphing it, you'll need to have your points. And you need to have the vertex plus, you need 2 on each side. So like, you need 2 points on this side, over 1, up 1, over 2, up 1, 2, 3, 4, and 2 on this side of the main line here. Over 1, up 1, and over 2, up 4. Get my point? 1, 2, 3, 4, 5. You need to graph 5 things to make a parabola. All right. This is a review of algebra, stuff that you knew when you took algebra for you guys, it was probably 7th grade. Now, you got to bring that stuff back. You got to be good at it because what we're doing today is going to involve a lot of this, multiplication and also distributing. All right, so I'd like you to do A, B, C, and D while I pause the recording here for a sec. Okay, let's get some answers here. For A, when you multiply the 3x and the 4x, you get 12x. True or false? False. It's 12x what? Squared. And if we didn't have a squared, it wouldn't be a quadratic. All right, then the 3x times the negative 5 makes negative 15x. All right, so that one, if I had just stuck a f of x in front of it, now I've got a quadratic function. It's quadratic because it's got an x squared in it. Notice, this is equal to this. Did the top one have an x squared in it? No. But it would as soon as you multiplied it out. So the moral of the story here is this is a quadratic, for instance. It doesn't have an x squared. But if you multiply it out, it will. And not only that, but it won't just have an x squared. X squared will be the biggest exponent, or the squared part will be the biggest exponent it has. Because otherwise, if I just say if it has an x squared in it, it's a quadratic, this would also be a quadratic then. And that's not a quadratic. And you guys know what that's called? It's got a 3 here. It's not quadratic anymore. It's a... Nope. You were thinking try because of the 3. I get that, but it's not a try anything. Cubed? Cubic. It's a cubic. You're right. All right, that's a cubic function. So anyway, I don't want to just say if it has an x squared anywhere, it's a quadratic. It's if the highest power that it has is an x squared, okay, or a degree of 2. All right, so this one, first, outside, inside, last, that ring a bell? You really need to know that inside and out. All right, so let's do first x squared, outside, negative 5x, inside, positive 3x, last, negative 15, x squared minus 2x minus 15. Raise your hand if you had that one right. Okay, so notice this one was a quadratic and it had only 2 terms. This one's a quadratic and it has 3 terms. This one was a quadratic and it ended up only having 2 terms. Why? Because the inside one's canceled out. Minus 7x and the plus 7x cancel. So you end up with x squared minus 49. So this one doesn't have any middle term. It has no x term. So this has 2 terms without any x. This one has 2 terms with an x. This one has 3 terms. So they can look a lot of different ways. And this one, how about this? Instead of saying what's the answer, for D, I warned you that there was a classic mistake you could make on that. Who wants to tell me what they think the classic mistake answer is? Lizzie. So you'd say x squared plus 9 would be the classic mistake. You are right. The exact right answer for this one instead is we got to go like this. X plus 3 squared means x plus 3 and x plus 3 multiplied. And this one comes out to x squared plus 6x plus 9. Raise your hand if you had that one right. Okay, good. So I'm multiplying practice here. My multiplying practice is because we're going to be talking a lot about changing from vertex form into general form. This red one here is in classic vertex form. To get it into general form, all I got to do is multiply it out, and I'll have it in general form. Now, vertex's form is really good for graphing. General form is not good for graphing, except on a graphing calculator. It'll work either way to type in this equation or to multiply it out. I'd like you to multiply out the red one there right now. Just multiply out the red one. Make sure your answer has an f of x in front of it. I'll pause while you finish that. So once I've got it that far, now it's x squared plus 4x, which makes 8x, plus 16, and then the plus 9. Final answer, x squared plus 8x plus 25. I was going to say y, but I should say f of x equals. That's general form. Okay, now general form has to have the one with the biggest degree first. The next one is the second biggest degree, and the last one has a degree of 0. All right. We'll do more on our next video. Part 2.